All right, guys, I have marked your fifth weekly test. Not as bad as I thought it might be, but still, I think there's a lot of misconceptions that are going on. Some of you really should be doing a lot better than you are at the moment, and I'm hoping that you're going to kind of get your backsides into gear here and get working. Um, just just go through some of these questions. Most people got this right, but or missed something small. Perhaps we dealt with it afterwards. It's just a reduction of a ketone cyclohexane ring. The T-butyl group is a locking group. It must be equatorial. Lithium aluminium hydride delivers an H minus. It's a reducing agent. It's kind of like an H minus, and that's a very small nucleophile effectively. And because it's a small nucleophile, it's going to prefer an axial attack. The axial position over there is facing up. So the product will have the OH group in an equatorial position, okay, facing down like that, and the T-butyl group, lost. The T-butyl group will be down as well. You can draw in this if you want, the hydrogen, but it's not necessary. So long as you show that the OH was going down, that's fine. Quite a few of you drew this out in the chair confirmation, and I'm not so sure. You didn't need to do that. Don't waste time trying to draw out chair confirmations unless it's specifically asked for. There's nothing there about in there asking for you to show the chair confirmation. This one was done relatively well, actually. I'm glad most of you saw that this was a Grignard reagent. And again, it's big, it's bulky, it's going to want to end up in the equatorial position. So the product will be, the T-butyl is up, it's up there, and this must also then be up. So going up towards aromatic ring, put the methyl groups on, and of course, if it's added over there, we're left with a a tertiary alcohol, which must be going down. All right, because down is the axial position there. This is equatorial, that's equatorial, and this must be axial. All right, which should make sense. This question over here, I think a lot of you spent more time on it than you actually needed to. All I was looking for over here is the recognition that this chiral center is changing. It's changing because an enolate is being formed, and it's changing because the product is the most stable, thermodynamically stable one, where the two groups are in an equatorial position, both of them are equatorial. So all you needed to show was that all you needed to show was that the enolate had formed. You didn't even have to show the mechanism or anything like that. So we have the enolate. All right, maybe put that as a equilibrium, and then it goes back after sort of protonation by the water. All right, so just either showing the enolate or mentioning that it goes via the enolate is the one part, and the other part is to say something that equatorial is more stable, and that would have given you your 3 marks. All right. Most of you, if you'd said something about the enolate, I would have given you 2 marks, but you didn't say about that. And, and if you said that the equatorial is more stable and kind of got that way, but didn't show the enolate, I would have given you 2 marks as well. So I try to be a bit lenient on that. And then the last question, well, I mean, this over here is the format. We've done this so many times. It's the formation of the silyl enol ether. And obviously this is now a chiral center, but this is going to be plus minus, because it's not going to be one enantiomer. We're starting with something that's racemic, or isn't even a chiral center anyway, and so this cannot be one enantiomer. But the important thing is, there were two things out of it. So one is testing your ability to do silyl-enol ether reactions using a Lewis acid, and pretty much everyone didn't get that. And remember, what happens is the Lewis acid is important for activating the aldehyde, which is a good electrophile, but not good enough for the TMS group. And so by activating that, it kicks off a chlorine, and this is a bit more reactive. It comes in, goes over there, and that can break. And so our product looks a little bit like this. O TMS plus bond going to O titanium Cl3 going to aromatic ring. All right, something like that. And then the Cl minus can break the TMS group off like that, and we can okay, let's just do this all. Just going through the motions of this. This is not really the main thing, because we've got to look at the stereochemistry. We're forgetting about this part. I'll come to the stereochemistry now. And we end up with titanium chloride, and it's important. And then this is effectively, it's like an O minus, isn't it? And we've got TMS chloride there, and so that can kick out the chlorine. We get this, we get a swap going on. The Lewis acid is regenerated with an O TMS, but the silyl-enol ethers, just putting a phenyl group there. Sorry, I'm doing this quickly. The silyl-enol ether is very, or this silanol is very unstable. If we add water to this, it's just going to protonate it. So if we add water, when we do the workup, maybe a bit of acid present as well, just weak acid, but water will do this. It's not very stable, and we just reprotonate that. We think of the TMS as almost like an H, right? And the phenyl and the OH. So this is the product. We're actually forming two new chiral centers, here and here. Well, also by analogy, I guess this one becomes a chiral center from not being one in the beginning. And we don't worry about this chiral center. I'm not dealing with that one. But the important thing is that at this point here, we've got a cyclohexene ring system, which is attacking an electrophile. And so the electrophile must come in. Axial attack is preferred. All right, axial attack is preferred. And so if this is up, all right, the incoming electrophile will be down. You should satisfy yourself in that. Let's just do it in this product here. Assuming this T-butyl group was facing up, then this over here, the product would be going down. Equatorial, equatorial up, equatorial down, equatorial up. So this down is axial. All right. So without having to do any twist boats, chair conformations, if you can do that, brilliant. I mean, that's great. I might give you bonus marks for that in an exam. But in this, you just need to know that the incoming electrophile must have come in axially, and so this is the preferred configuration at that carbon. That's what I needed you to see, and I gave you 4 marks for that. I've drawn out the entire mechanism. That's just because I did this now for your sake. But that wasn't where the marks were. All you needed to have been able to do was to give me this. I would have given you a mark for that. Given me the product, all right, with the correct stereochemistry, and you would have got the marks for that. All right, and maybe somewhere just to make sure that you can mention that axial attack is preferred. All right. Okay, and then I would have given you all the marks for that. Okay, so that's the end of this one. I'm hoping that by the end of next week or the next week's tutorial test, which will be the last one, and the tutorial we have next week, will hopefully kind of cement all this for you guys. All right, cheers.